All right, so this is going to be a quick video about estimating derivatives at a point. And the problem that I'm going to use to teach this concept is from the 2018 AP Calculus AB free response questions that were released on AP's website. The particular problem I'm looking at is number 4. Now, I don't plan on doing all of this problem. I'm actually only focusing on estimating derivative at a point. So what I'm going to do is actually get rid of most of the problem here to focus on A, because again, this video is just on estimating derivatives. Okay, 4A is all about estimating derivatives. So it says right here, the height of a tree at time t is given by a twice differentiable function h. Now this twice differentiable function h, this twice differentiable, don't get too hung up on that. It just means the second derivative does exist. You might need that in some other part of the problem, but for this problem right here, we're not actually going to need to know that information. Okay, and it says where h of t is measured in meters. Okay, it says that right here, this is in meters. And then t is measured in years. It says that right here. So it's kind of already in the table, but it's still good to read through that. Selected values of h of t, okay, h of t is right here, are given in the table above, and it says using the data in the table, estimate h prime of 6, okay? Now, this 6 right here represents the t value, and if you notice there is no 6, it goes 2, 3, 5, 7, 10. So 6 would be like somewhere right here between 5 and 7. So we're looking for h prime of 6. What I'm going to do is use t equal to 7 and t equal to 5 to find that derivative, and really it's just an estimate of that derivative. It even says that right here, estimate h prime of 6. Okay, so the first thing I'm going to do is write h prime of 6, and it's an estimate, so I'm going to have the approximate symbol there. And to do this, what I'm going to do, I still want change of y over change of x. Now our y in this case is h of t. So I'm going to find the difference between the h of t. So we're going to find the difference of h of 7 and h of 5. I'm going to write that in like that. And then we're going to divide this by 7 minus 5. Okay, now what this is really doing is it's finding the average rate of change between 5 years and 7 years. Now that average rate of change is going to be the closest we can get to finding what h prime of 6 could be. That's why this is considered an estimate. Okay, from here, h of 7 right here is 11. So I'm going to write equals 11 minus h of 5 is 6. So I'm going to put a 6 in there. And then we're dividing this by 2 because it's 7 minus 5. And then we just end up with 5 over 2. Okay, that is the estimation of h prime of 6, but it says using correct units, interpret the meaning of h prime of 6 in the context of the problem. Okay, so the correct units would be whatever the units are up top here, which in this case it would be meters minus meters is meters, all right, so we're going to have meters here. And then on the bottom, we're going to have years. So this was meters and this was years. The years, it says it right here. Okay, so it'd be meters per year. So 5 over 2 meters per year, or you can say 2.5 meters per year as well. Now it says interpret the meaning of it. Okay, so I did the correct units, but I still need to interpret the meaning of h prime of 6. So I would write something like this. At 6 years, okay, so I'm going to start with what the 6 actually represents. Okay, now the prime right there means rate of change of h. So I'm going to write at 6 years, the rate of change of, and we're doing the rate of change of h. So I'm using every single symbol here, the 6, the prime, and the h. Capital H represents the height of the tree. The average rate of change of the tree height is, and now it's an estimate, so I'm going to write about, is about 2.5 meters per year. Okay, so that's basically how I would answer a question like this. It's a full breakdown here. I showed how the estimate of a derivative at a point comes into play. I also interpreted the meaning of h prime of 6 with using correct units. AP puts at least one of these problems on every single one of their tests, so it is really important to understand the gist of how to do these because you're going to probably see it if you are taking the AP exam, or your teacher will probably give you problems similar to it on their test. So that's estimating derivatives at a point. If you have any questions about anything in this video, let me know.